Hello everyone, Jacob Foster here, and today we are going to do a problem that involves taking the first derivative. I don't know how far along in calculus you are, if you're past calculus, if you're just starting calculus, but we're going to start with a review of the tangent line problem, which is vital in understanding what you're really doing by taking the first derivative. First, let's go over slope. Slope of a line is y2 minus y1, x2 minus x1. It's delta y over delta x. Change in y over change in x. And when you have a linear here, it's very easy to kind of see where those numbers come from. You have x1, x2, y1, y2. And you can plug those right into the formula, and it's real easy. It's just straight algebra. Now, here when we go into the curve, what the tangent line problem is about is finding the slope of a curve. And the thing about a curve is that it isn't straight at all. So it has a variable slope. Every single point could have a different slope. So those numbers aren't as simple as a linear function. You have change in y up here, change in x over here. It's all different. So what we have to do is create a whole new formula, and this is going to be called the difference quotient. So let's plug into our original slope formula, delta y over delta x, because it's all exactly the same. So you have delta y over, let me change colors here, keep it color coded. And that is going to be, if we're following this, we're going to have delta y on top, which is y2 right here. Actually, we don't need the function anymore, huh? No. X plus delta x minus x. I'm going to put this in brackets for right now, and we'll discuss that later. That's going to be all over delta x, which is x plus delta x minus x. And these two x's right here are just going to cancel out. So our final difference quotient, this is what it's called, the difference quotient, is going to be x plus delta x minus x all over delta x. And this is what we need at the beginning to take the derivative. Any function we plug into here, we're going to be able to essentially take the derivative. And we're going to do that through the limit process. So hopefully you have a pretty good understanding. You need a pretty good understanding of the limit process to go ahead and do this kind of a problem. And I'm going to go ahead and erase the board, and we're going to start over. We're going to get our function, and we are going to get started taking the derivative. Okay. Alright, so now that we've gone over and discussed the tangent line problem and where this difference quotient comes from, we're ready to move on. And really, this part that we just got through, the reason we are discussing this and going in depth is because this is a critical part of calculus, and it's the most important part, is understanding what's behind the numbers, what's behind the math that you're doing. And this isn't a new formula. Just never lose sight of that. It's slope. It's nothing more than delta y over delta x. It is the slope of the tangent line to the curve of the function. So we're going to plug any function into this. We're going to get a tangent line, and that is what we get. We get the slope of the tangent line. So now we're ready to move on. We're ready to plug a bad boy into this difference quotient. We're going to plug in this function right here, the square root of x plus 4. And I suggest before you go and attempt doing this that you go and try some easier ones, because finding the derivative of a square root can be a little bit tricky at first. But you will get the hang of it. Just keep practicing, keep going at it. So go, pause the video, go and do a couple examples, learn how to plug into the difference quotient, and then come back and look at this, and I promise it'll help. Alright, so let's get started here. Let's plug this into the difference quotient. And we're going to do this by the limit process. Just as you are familiar with the limit process, as you have to be, you're going to know that our first line of attack is substitution. So we're going to plug this into the difference quotient here. delta x goes under the radical. It's very important. Don't forget to put delta x under the radical. We're going to subtract that by just the function. It's all over delta x. Okay, so there we go. We just plugged in. Now we are going to substitute 0 in for both these delta x's. And up here it's fine, but down here not so much. This delta x is kind of screwing things up here, because if you plug in 0 there, it's empty set, no solution. You can't divide by 0. It's not allowed. That's like the worst crime in math that you could possibly commit, other than forgetting a negative sign, which is also why we are going to put this in brackets, so we do not forget to distribute this negative when the time comes. Moving on, though, how do we get rid of this delta x? This delta x is the bad guy. He is the Wicked Witch of the West. He is Draco from Rocky IV. He killed Apollo Creed. He's trying to steal your ruby slippers. He's the bad guy of this terrible movie that we call math. You gotta get rid of him. But how do you do it, You're the good guy, you're the hero, it's all on you, this is all your responsibility, but how do you do it, really? How do you send something down here to cancel out this delta x? 'Cause that's what we gotta do. We gotta create an algebraic expression that could somehow cancel a delta x in the denominator, but there's nothing in the denominator, and the stuff up top is in square roots. And how do you send that down? If the square roots were in the bottom, we could send them up by rationalizing the denominator, but we can't do that in the numerator now, can we? Can we? Oh, I'm sorry, guys. My associate tells me that we can rationalize the numerator, and it's a very simple process, actually. He tells me it's the exact same as rationalizing the denominator. In years past, you might have rationalized the denominator in Algebra 2 and pre-calc, but now, the time comes where men have to make hard decisions, and we have to deport this guy back down to where he came from, to fix the problem that he left. And it's not his fault completely. It's probably a little bit our fault. But you know what? Survival of the fittest up here. So what we're going to do is we're going to multiply by the conjugate. And it's not really the conjugate. All we're really doing is creating the difference of two squares, but I think you understand what I mean. What this is going to do, it's going to create the difference of two squares. It's going to cancel out these radicals. It's going to send something down here to the denominator, and it's going to help us out in combating our foe here, delta x. So we're going to rewrite here and see if we make sense of this. Limit as delta x approaches 0. That's another felony. Don't ever forget to write limit. Always write limit until you substitute. Until you plug that 0 in, always write it. So limit as delta x approaches 0. The radical is gone. Plus delta x minus x. And here we go. We're plugging in. This radical is gone. We're plugging this negative in. We're distributing it. So we distribute it to x, change that sign, distribute it to 4, also never forget. There we go. There's our top. And our bottom is going to be delta x times square root of x plus 4 plus delta x plus x plus 4, square root of x plus 4. And there we go. There's our bottom. So we have plugged in the difference quotient. We have rationalized the numerator. Now we got to see if we can cancel anything out and simplify and get rid of delta x. Because still, if we plug in 0, it's still going to equal 0. So let's start up here in the numerator. We see that we have an x, a negative x, 4 and a negative 4, and these are going to cancel. It's looking good. We're looking pretty solid. Things are looking our way. It's the rising action of the plot right now. And look at this. We've reached the climax. Delta x have been canceled. There's nothing but a delta x left on top and a delta x on the bottom. You can cancel those suckers right out. So there we go. That's calculus. It's done. The Wicked Witch is dead. Ding dong. Boom. It's over. All we gotta do now, we gotta simplify. We gotta substitute 0 in for the remaining delta x's right there. And we're good to go. Calculus, baby. Boom. So we substituted in. We no longer have to rewrite limit. 1 over. There's nothing left on top. It's just a 1. 1 over the square root of x plus 4 plus 0 plus x plus 4. And this 0 is going to be nothing. I mean, can't really do anything to anything else. And it's x plus 4, 1 over x plus 4 plus x plus 4, which is going to equal our final solution, 1 over 2x plus, wait, no, 1 over 2 square root of x plus 4. My apologies. And there we go. You just treat that like a variable. And that's calculus for you. We just took the first derivative. You know, that is a very long process. But the algebra isn't hard, and as long as you keep the concept in your mind that this is the slope of the tangent line right here. Slope of tangent line. Right there. That's all it is. And there's your solution. You just took the first derivative. And it might have been hard, it might be a little bit difficult at first, but just keep practicing, keep going at it, and I promise it's going to get a lot easier until you get to optimization, and then it just all goes back to this. So, yeah, there you go. That's it. Jacob Foster. I hope you enjoyed.